Awesome.
Well, I was yelling at.
My wife is pregnant right now with our first child, and when people see her with her big baby bump, the first question people ask, almost without fail, is it a boy or is it a girl? Now, there's some assumptions behind that question that we take for granted because of our familiarity with our own human biology. For human babies, we take it for granted that there's a 50-50 chance of either answer, boy or girl. But why is it that way? Well, the answer depends on the sex determination system that has evolved for our species. You see, for most mammals, the sex of a baby is determined genetically with the XY chromosome system. Mammals have a pair of sex chromosomes, one passed down from mom and one from dad. A pair of X's gives us a girl, and an X and a Y together gives us a boy. Since females only have X's to pass on in their egg cells, and males can give either an X or a Y in their sperm cells, the sex is determined by the father, and the chance of producing a male or a female is 50-50. This system has worked well for mammals, but throughout the tree of life, we can see other systems that have worked just as well for other animals. There are other groups of animals that also have genetic sex determination, but their systems can be pretty different from ours. Birds and some reptiles have their sex genetically determined, but instead of the sex being determined by dad, their sex is determined by mom. In those groups, a pair of Z sex chromosomes produces a male. So these males only have Z's to give. However, in these animals, one Z and one W chromosome together as a pair produces a female. In this system, the chance of a male or a female is still 50-50. It just depends on whether mom puts a Z or a W into her egg. Certain groups have taken genetic sex determination in completely other directions. Ants, for example, have one of the most interesting systems for determining sex, and because of it, if you are a male ant, you do not have a father. In an ant colony, there are dramatic divisions of labor. There are soldiers that defend the colony, there are workers that collect food, clean the nest, and care for the young, and there's a queen and a small group of male reproductives. Now, the queen will mate and then store sperm from the males, and this is where the system gets really interesting. If the queen uses the stored sperm to fertilize an egg, then that egg will grow up to become female. However, if she lays an egg without fertilizing it, then that egg will still grow up to be an ant, but it will always be a male. So you see, it's impossible for male ants to have fathers. And male ants live their life like this with only one copy of every gene, much like a walking sex cell. This system is called the haplodiploid system, and we see it not only in ants, but also in other highly social insects like bees and wasps. Since our own sex is determined by genes, and we do know of these other animals that have their sex determined by genes, it's easy to assume that for all animals, the sex of their babies still must be determined by genetics. However, for some animals, the question of whether it will be a boy or a girl has nothing to do with genes at all. And it can depend on something like the weather. These are animals like alligators and most turtles. In these animals, the sex of an embryo in a developing egg is determined by the temperature. In these species, the sex of the baby is not yet determined when the egg is laid, and it remains undetermined until sometime in the middle of the overall development period when a critical time is reached. And during this time, the sex is completely determined by temperature in the nest. In painted turtles, for example, warm temperatures above the critical temperature will produce females within the eggs, and cool temperatures will produce a male. I'm not really sure who came up with this mnemonic, but you can remember that when it comes to painted turtles, they are all hot chicks and cool dudes. For some tropical fish, the question of will it be a boy or will it be a girl isn't settled until even later in life. You see, clownfish all start out their lives as males. However, as they mature, they become female. They also...
So what sex was Nemo, really? If he was a baby, then he would be male, right? But then he would become female. I don't know. This one's usually one that's like people are like, oh my gosh, you mean his dad is really his mom?
Be a boy or will it be a girl isn't settled until even later in life. You see, clownfish all start out their lives as males. However, as they mature, they become female. They also spend their lives in small groups with a strict dominance hierarchy where only the most dominant male and female reproduce. And amazingly, if the dominant female in the group dies, the largest and most dominant male will then quickly become female and take her place, and all the other males will move up one rank in the hierarchy. In another very different ocean animal, the green spoonworm, the sex of the babies is determined by a completely different aspect of the environment. For this species, it is simply a matter of where a larva happens to randomly fall on the sea floor. If a larva lands on the open sea floor, then it will become a female. Top of a female, then it will become a male. So for some species, the question of boy or girl is answered by genetics. For others, it's answered by the environment. And for others still, they don't even bother with the question at all. Take whiptail lizards, for example. For those desert lizards, the answer is easy. It's a girl. It's always a girl. They are a nearly all female species, and although they still lay eggs, these eggs hatch out female clones of themselves. So will it be a girl or will it be a boy? Throughout the entire animal kingdom, it does really all depend on the system of sex determination. For humans, that system is a genetic XY system. And for me and my wife, we found out it's gonna be a baby boy.
Wow. Okay, so let's go over these questions. All right, so for people and other mammals, let's see if it lets me write on it. All right, who wants that one? People and other mammals. Okay, so sex is determined by dad. So he's XY and mom is XX. Okay, so King Henry VIII had several wives killed because they couldn't give him a male heir to the throne. So whose fault was it all along? His, yeah. So it just happened that his sperm, maybe the sperm that fertilized the eggs, were just X sperm. So according to this, if we put it on a Punnett square, y'all remember, we're going to get into Punnett squares in the next unit. Do y'all remember these from maybe 7th grade or something when you had to do the DNA, the different traits? Maybe. So we put the guy, what's the chance his sperm will be, in his sperm, he can either put an X chromosome or Y chromosome, because we only give half your genes to your kids, right? You don't give them all. And then for a girl, our eggs can only have an X in them. So what's the chance at any time, really, that you can have a male or a female? Once we fill this out, 50-50, half and half. You're right. So technically, there's a 50-50 chance that at any time that you will have a boy or a girl. Well, there's some other things that play into it for us. Dad still determines whether or not you have a male or a female. But female, the sperm that have the X chromosome seem to live a little longer. The Y sperm doesn't live as long. So that might be a factor. And then have you ever noticed how some families, like male families, it seems like they have more of one sex than another. Like they have more sons or they have more daughters. And so there's different reasons for that. I know back when I was in college, one theory was that if a male smoked a lot of weed, then he would decrease his Y sperm and he'd have more X sperm. So that was one theory. So I don't know. I haven't found that. I mean, what else determines that? But so far, it's always the guy. It's never the girl's fault. And I can remember watching these shows like Little House on the Prairie and these like shows from way back when, and these women felt so bad that they couldn't give their husband a son. Well, it wasn't her fault all along. So, all right. So Sienna's got that one. All right. How about birds? Somebody else tell me birds. And then everybody's going to tell me something. So think of another animal that you heard about. What was the deal about birds? Craig, what did they say? Which determined the sex of the kids, the mom or the dad for birds? Right. So does anybody remember what they use different letters? I mean, we could use X's, I guess, but they use Z's, I think.
Yes.
Okay, so Elizabeth, tell me for a dad. Double Z. Okay, and then what was the mom?
C and W.
Yeah. So all the male birds out there, they don't determine sex. It's the mama bird that does that. So half of her egg should be Z and the other half should be W, which is kind of neat. Who are the beautiful birds in the world? Are they the moms or the dads?
The males.
Why would a dad look better than a girl? Why would it be important in nature for the dad bird to look nicer?
Probably so other animals won't eat the mom.
Right, it's a decoy. It's a big reason. So y'all know what the red-bird cardinals are?
Yeah, that's my favorite bird.
So it's one of our state, isn't it our state bird? One of them. We have all these state animals. I don't know half of them. But the cardinal is beautiful. And then the female cardinal is kind of beige. And she has an orange little beak. But she's kind of a beige color. So she has more camouflage. She's sitting on her nest and incubating the egg. So the predator will see the red one. But another reason is, think about peacocks. So a male peacock has these beautiful feathers and he struts around. So why do you think he wants to look good? To get all the attention. He struts around, not any different than you see guys who are trying to get a girl's attention and they puff out their chest and they kind of strut around and they walk around and it's like, oh. So, but it's courtship. So they do that automatically. All right, 2 other animals. Okay, tell me about fish. Okay, so the clownfish. Put clownfish. Start as males. Okay. And then what happens to them? So, and they become female. Okay. So, so Marlin, wasn't he the dad of Nemo? Marlin, I think. He really should have been a mama. He shouldn't have been. So that's one thing that bothers me about a lot of these Disney movies and these cartoons is they really don't do their homework very much. And then everybody learns animals to be like a Disney movie. And it's like, oh, no. It's like the Bee movie. Y'all seen the Bee movie before? The buff bees flying around pollinating. They're not supposed to be boys. All the girls do all the work. If you see any bees pollinating, they're females. So the guys are back at the hive, trying to reproduce with the female and or with the queen. All right, Caleb, Alexis, give us something. What's another animal you saw or you heard?
Oh. I had the turtles.
Oh, okay. And this is true too, like with the giant tortoises. Okay, so with turtles, all right, what did it say about turtles?
It was based on the temperature.
Yep.
Hot is female, cold is male.
So if an egg can be the DNA inside the egg, go back. The DNA inside the egg, dadgummit, look at that. The gene can switch either way. So I don't know what just happened, but oh well. So you said cool dudes and hot chicks. I love that. So if I'm a sea turtle and I just laid my eggs like on the beach, let's say May, June, and it's still a really cool spring, If they don't get warm enough, what sex are they going to be? Yeah. And what's interesting is, where does the sun going to heat up the nest the most? Because they put them in, the clutch of eggs is actually, buried down in the sand, and they pile it up. So where would the warmest part be, Alexis? Where do you think in the nest? The sun's beating down on that nest, and you've got this clutch of eggs. Let's say here's the mound of sand, and you have all these eggs right here. And I just put a whole bunch of them in the sand. Which ones are going to turn into be females? According to that. The ones at the top or the bottom? Which ones are going to heat up the most? So down the bottom, so have you put your feet in the sand before? Have you ever been to the beach? Put your feet down in the sand? What's the sand feel like? On top it's hot, but when you really put your feet down underneath, what's it feel like? It's cool. So the cool dudes will be here. Hot chicks will be here. So you may see more females on top that hatch, and the males are at the bottom. So it doesn't mean the whole nest is either or. So it's kind of cool. All right, give me something else. What about those lizards? You know what they said about the lizards? What are they all born as? What sex? All females. So an all female species. It's kind of crazy. Makes you wonder why, why did that happen? How about the worm? The sea worm.
Larvae?
So the larvae is like a maggot. It's like a caterpillar. So they have a little larvae, and it swims. And then as it falls, bam, if it hits the bottom of the ocean. Isn't that weird? So it just shows you that they have genes. They have genes to be either sex, and the sex, it just cuts on. So, all right. So it's kind of neat. Interesting that there's other ways, not just what we're learning about X and Y chromosomes. Okay, I want to show y'all the amnio little video about how do we get a picture like this from that test. So I can go back. I think it's back one. Here it is. Hopefully it'll show it. Let's link. Nope. All right, so I've got it, or I had it up here.
Did you get your beverage, Miss Lynn?
I did, thank you.
Sorry to keep cutting through. We're using a lot of water today.
Oh, that's good. That's a good problem to have.
That is.
Right. All right, here it is. It's real short. So this is what they would show an expecting mother.
Amniocentesis is a procedure that lets doctors detect or rule out problems with your baby's health long before.
All right, what is this thing? Don't know what that is.
It's
Because I would probably have really known what that was until I had kids.
it's what it would be like sonogram.
It's the ultrasound.
Oh,
Yeah, it is. It is. And they use that too if they do an ultrasound. I had an ultrasound from a mass that was growing. And ended up, they did an ultrasound of it and got to see a picture before they removed it. So, yeah, it's just going to, that's the ultrasound. They put that little jelly stuff on there.
Interruption, teachers, please dismiss all trio students. Please dismiss all the trio students who are going on the field trip with Ms. Ragland. Again, please dismiss all trio
Before
students who
birth.
are going on.
In the uterus, your baby is surrounded by amniotic fluid that provides protection and nourishment. Floating in the fluid are cells from your baby, providing doctors with genetic material for testing. In amniocentesis, your doctor will take a sample of this fluid to test for specific genetic disorders and birth defects. Amniocentesis is usually done in the second trimester of pregnancy at 15 to 18 weeks. It is generally offered to women with certain risk factors, age 35 or older, which increases the risk of chromosomal disorders such as Down syndrome, a previous child or pregnancy with a birth defect, blood test or ultrasound suggesting a birth defect such as Down syndrome or neural tube defects, or a family history of genetic disorders such as cystic fibrosis. Amniocentesis may also be done in the 3rd trimester for these reasons: to determine if the baby's lungs are mature enough should early delivery become necessary, to diagnose a uterine infection, or to check for anemia in a baby with Rh incompatibility. To begin your procedure, your doctor would use ultrasound to create an image of the fetus and nearby structures on a computer screen. Looking at this image, the doctor can choose a safe place to insert the needle. Your doctor may give you an injection of local anesthesia to numb the surface of your abdomen, where the amniocentesis needle is to be inserted. Carefully watching the ultrasound monitor to avoid contact with the placenta or the baby, your doctor will introduce the thin needle through your abdominal wall into your uterus and into the amniotic sac. He or she will then withdraw a small sample of amniotic fluid, remove the needle, and cover the site with a bandage. Your body will make additional fluid to replace what was removed. Your doctor will continue to monitor the ultrasound to check that the fetal heartbeat is normal and the baby tolerated the procedure well.
Okay, so, well, I can't really see it.
You may feel mild cramping or pressure in your lower abdomen. For about 24 hours after your procedure, you will be advised to avoid physical stress, such as vigorous exercise, lifting, prolonged standing, and sexual activity.
Okay. So that's what they do to actually make this test that we're looking at. All right, so let's see what some of these words are about chromosomes. Okay, so yesterday we looked at the structure of a chromosome, and we had 2 different identical parts. So what were both of these identical parts of a chromosome called?
Identical sister.
Identical sisters, sister chromatids. So they have the exact same DNA. All right. And we're going to practice some of the stuff with whiteboards where you guys will be drawing and all that kind of stuff. All right. What is this middle part called? Somebody else. What holds it together in the middle? And its name kind of means sense, like the center. Centromere. I think I kind of squeezed it in there. So centromere. Yep. All right. So that's the structure. And then we said it forms because it looks like a hot mess of chromatin. And then so the hot mess of chromatin, and then it wraps around some proteins in order to try to organize itself into these chromosomes. So if we have 6 feet of this chromatin inside every one of your cells, it's got to keep wrapping and wrapping to make these chromosomes. So we said it kind of wraps around like this. So what are those called? What are those proteins called? What do we call them? We said the chromatin wraps around something. Yeah, histone proteins. Okay. Alrighty. So chromosome types. Okay, so there are 2 categories. One of them we circled, I believe, didn't we? 1 through 22. All right, that's one type. And then we have the last pair. Okay, so now what do we call 1 through 22? What do we call all those? The non-sex determinant chromosomes. What was the name for those? All right, we'll come right back to you. Caleb, what's the last pair of chromosomes called?
X and Y.
What are they called in general?
The sex chromosome.
Yeah. So we got sex chromosomes. And then, Annette, you got the other one? What kind? Autosomes. Yep. So people usually say autosome, like autosome, but autosomes. All right. And then we have these two things to do. So that's what we have left to do today that's new. But we're going to go ahead and back up and look at your homework. So what you're going to do is just bring your chromosome up and tell us what 3 genes you found. And that's it. Okay. And then what we're going to do with all of these, we're going to take your class and the other team, we're going to make a big karyotype. It's like this. So there should be 2 chromosome 1s and 2 2s, and we're going to put them out and make one big giant karyotype. We're going to put it outside on the wall. So we'll be able to use your stuff. Okay, so who's up first? Okie dokie. And then if you did extra credit, let's pull this up. Just tell us what that is. Run out of the way. Okay. What you think here?
Mine was number 7. This is GCK diabetes, like this part. This is syphilis, fibrosis, and then obesity is down here too, somewhere in there. And then Pendro syndrome. So PPS.
Good. All right, so cystic fibrosis, we're going to find out more about. What do y'all think about it? What's obesity? What does that mean? Huh? Overweight. So, do y'all know people who really just have a really hard time struggling with their weight?
Yeah.
You know, and it's like people that will say, I don't eat much. I don't, it's hard for me to exercise. I really don't eat a lot. And I'm trying to, it's like their metabolism shot. Well, they probably have that obesity gene. They probably have 2 of them. That's the folks that we find that they may end up having some surgery and things that will help them lose a lot of weight. Then if you have one of those genes, then it may be that you just can't eat everything. You're going to have to watch it. You know, you may have a tendency to put on some weight. But if you've got 2 of those genes, those are the folks that you may see. It's just like, oh my goodness, you feel sorry for them. And it's hard. So, okay, nice job. Good.
Because in my family, the obesity and cystic fibrosis, how you say it, and the diabetes in my family.
Cystic fibrosis is? Really?
It's all on my dad's side.
It's in white, it's more often seen in white people of European descent, cystic fibrosis. Like sickle cell is more of an African American disease because it evolved in Africa. Cystic fibrosis must have evolved like in Europe. Wow. When we talk about that, then I want to hear more about it. Okay, next. Elizabeth, let's move, girl. Let's see. Annette, you got yours? Caleb, you got yours?
I haven't finished my last time.
What do you have?
That's it.
All right, well, you can present your information and then do the other part. Okay. All right. Oh, wow.
I got chromosome 3. This part right here is 1 nipple. I don't know how to say that word. This part,
No idea.
right here, it's lung cancer. This little part is colon cancer. And right here, I kind of messed up. Well, I drew. It's supposed to be white a little bit right here.
Uh-huh.
But it's essential tumor.
Huh.
And it contains about 1,090 genes. Contains 200 million base pairs, of which 95 have been determined.
So the Human Genome Project is not totally done. I'll go on a different website, you'll have different numbers for stuff. I mean, if it's relative, like I found for my chromosome between 500 and 600 on one and 800 on another site. So, you know, you just don't know, but, wow. So 95%. So your model had 6 base pairs. And we're saying that on this one, there are 200 million base pairs. Wow. Okay, nice. So those 2 cancers are right next to each other. Okay. All right. Okay, you got yours? Got your info? All right. So you need to turn it into me, at least get a late grade, on Monday.
Okay.
All right, Caleb, let's see, Alexis or Caleb, you want to give us yours? Tell us what you got. You can show us the other, give us your info, Caleb. Tell us what genes you found, like what chromosome you have and all that, and then you can turn the other one.
Okay, well, I had the chromosome 5. Yeah. Chromosome 5 spans about 181 million DNA building blocks and represents almost 6% of the total DNA in cells. You're going to have to help me on this word.
Oh, just stick it under there. I'll look at it. So,
That one right there.
myelodys. Is it splastic
Yeah.
syndrome? All right, what is that?
It's a type of bone marrow disorder.
My dad has that. It's where it eats like bone marrow. My dad has that one, but he breaks his bones with it.
Oh,
It looks like when they done X-rays with it or that bone marrow, it looks like little worms came through the body, bone marrow.
wow.
Doctors are trying to figure out if I have that in my knees right now because they don't even know.
Huh. Wow. Okay. All right, what else did you find? What else were your?
Deletion of the DNA in chromosome 5 can cause blood disorders. Let's see. There's 1,700 genes and contains 100 million base pairs. And only 95% of it has been determined.
Wow. So what you're gonna notice is there's some gaps in there. So not every little band actually determines a trait. So we have a bunch of junk DNA, it's called. And so why do you think it might be a good thing to have some junk nothing DNA in between the good DNA? What would that help maybe do for the good gene DNA? If you had some kind of junk DNA in between, it'd be like having blank pages in a book and then you have pages with words on it and you have blank pages. Why do you think that would, how would that influence having like a mutation or something? What do you think?
They can probably use the DNA from the blank one and put it with the good one.
So if it's right there, it doesn't do, it's like you're reading blank page, oh, there's a gene. Here's a recipe. There's blank and blank and blank. So what if there was a mutation in the blank pages? They still have letters, it's just that they don't make anything. It's like nonsense. So if there's a mutation in the nonsense pages, does that make a difference? So it really does protect. I mean, it protects other genes, kind of keeps them intact. So then if there is a mutation, it can be like a whole part of it, like a part of it can be deleted, which would be terrible, or substituted. All right, good. Nice. Okay, so let's move on, y'all. We're down to number 3, and then we'll jump up for number 4. So let's go back to these notes. And is yours? Did we write female and male on yours? Okay, so, oops. Make sure I write this so that way I won't keep asking you if this is yours. All right, so let's go back and see what we have. So we know that we have 46 total chromosomes in our body cells. We get half from each parent. We know what they look like, the parts of them, and then how they're made. We said they're packages of DNA and protein, and there's 2 types, which we said. So we have, let's go back up to the top and fill in what is a karyotype. Since we started writing on a karyotype, we're going to go ahead and fill that in. And then we're going to look at some of the diseases, and we'll show you some pictures of some of these, of what the people would look like. And a little bit when you get up. So, all right, so a karyotype. If I tell you that this is a karyotype of one kid, and you've got a karyotype of 2 different kids on the back, what is this? Like, how would you put this in your own words? If this is a karyotype of one person and this is a karyotype of another person, what's a karyotype a picture of? What are those things? What are these things? No, what are these? What's each thing? Chromosomes. So if there's 46 here, that's a full set. So we're going to say that a karyotype is a picture of a full set of chromosomes from one body cell. Okay, so full set for us being 46. I don't know why that keeps cutting off. Sorry, here we go. A little bit bigger. Okay. All right, so picture a full set of chromosomes from one body cell. Okay, so what a full set means, there's a word that means that you'll have to know. And so if you go over to the left, there's 2 words, diploid and haploid. One is 2n, like in algebra, 2 times whatever that variable is, and then 1n, or 1n, or it just may have n. So how many chromosomes do you have for each number? How many do you see right there? 2. Why are there 2? Where'd you get 2 for each one? Right, one from mom and one from dad. So 2 means di or bi, diploid, 2. So this is, diploid is another word for a full set of chromosomes. So a karyotype is a full set of diploid, or a diploid set of chromosomes. So a full set of chromosomes in a body cell. Shows homologous pairs, okay? And we're going to label that. 1 from each parent. Okay? So we're going to label that on the back after we get that. We'll flip it over to one of those karyotypes and label a homologous pair. Okay, so that means every one of your trillions of body cells all have the same number of chromosomes, diploid set, because you got half from each parent when you were made. Okay? So we'll flip it back in just a minute. But let's go ahead and label. So here would be a homologous set of chromosomes. Number 1, number 2, number 3, like that. So each of these, what do you notice about each pair?
They're the same length.
Yeah, they should be the same length. If we stretch them out, they should be the same length. And I don't know if you can really tell, or you can tell more on these, on the bottom ones. Can you tell that they each have like the same little genes on them across from each other? So each little line. So that's what these are. So each one of them, this represents a homologous pair. So we have one from dad and one from mom. So same size end with same genes. So how many homologous pairs do you see for this girl? If you look down to all those pairs, if they look the same and they have the same genes, the same number, how many pairs does she have? Close. Is that last pair an X and an X? So that's 2 of the same 2, right? So technically, if you're a female, you have 23 pairs of homologous chromosomes. They all should be the same. Okay, so when you're a guy, though, how many homologous pairs do you have? 22, you're right, because this one's not the same. So what's interesting is this. Have you ever wondered if you have a sister and you have the same parents? Why one of you might act more like your mom and have more traits like your mom, and the other one more like your dad? You ever noticed that? Or in people? And our twins, because they're supposed to be identical, that means their DNA should be identical. The weird thing is with our twins, though, and I had this discussion with their Dr. Loda, who's one of their doctors. So, it's interesting to me because Mary Evan, who's the bigger one, she's always been bigger, taller, weighed more. And that's not really the reason, but she has more traits like me. It's like she doesn't have as bad of allergies. She doesn't have asthma. There's certain things that she doesn't have. But the other twin, Sarah, has asthma like my husband, and her allergies are worse. And she told me this. She said that even though they have 2 X chromosomes and they're supposed to be identical twins, that one of those can be more active than the other. So it's called bar bodies anyway, but one can actually be more active than the other. So I thought it was kind of interesting. If you ever wonder why 2 twins are supposed to be a lot alike, and it's like, why are y'all not really alike? That might be the reason. Okay, so you're not going to give all those chromosomes to your kids. You're only going to give half, right? Mm-hmm. So in half Lloyd, it's 1 in, half a 2 in? Yeah. So what I want you to think of is half, okay? Half of a full set of chromosomes. So what kind of cells do you make would only be half of your chromosomes? What kind of cells make a baby? Right. So these are not your body cells. These are going to be your gametes or your sex cells. So we're going to put sex cells or haploid. This would even be true for pollen for a plant, being sperm. So they're called gametes. Okay. So you'll see any of those as sperm, egg, sex cells, gametes. So they have half the set. So we have 23 in ours, and then it'll be 46 in the full set. Oh, it keeps blinking. I want to cut this off. Oh, so okay right now. All right, we good? All All right, so in order for you to be able to diagnose the patients, okay, that we've got around the room, there's 6 kids. Let's make sure y'all know what these diseases are, okay? And you're gonna use these as your cheat notes, okay? All right, so look at this first one. Do they have all 46 chromosomes? If you look at them and count by 2, do you see 46? Are they all paired up 2 at a time?
Yeah.
Okay. So just by looking at chromosomes, we would say it's a girl and she looks normal. Okay, just by this test. Okay, but let's make her have Down syndrome. So let's say that we look at this and we see an extra number 21. Okay, so let's give her a extra 21. Draw one in there, right there on 21, and we're going to say this is called trisomy 21. Now, why the tri?
Means,
What number does tri mean? Tricycle, 3. So we have 3 21s. Okay, well, that's not bad. It just means you have 3 of something, whatever those numbers are. But we call it Down syndrome. So if you go around and you see anybody that has 3 21s, they definitely have Down syndrome. And we'll see a picture of somebody that looks, that has Down syndrome. And y'all have probably seen people that have it. We have a student here at our school, a former student of mine last year, whose brother has Down syndrome. Okay. All right. So that's that one. Okay. Now let's go back over to this girl and let's say, well, she's missing an X. She only has 1. So if this girl here only has 1 X, and we call it XO. Okay, so it'd be like this. You look at it, and for number 23, you just see 1 of them. The O is a placeholder. So that means that they have Turner syndrome. She's still a female, but she has Turner syndrome. And Turner's is one where she's sterile, okay, so she can't have children. She's shorter. She may have like kind of thicker kind of neck. There are some other issues. Okay, so I'll show you a picture of what Turner's looks like. And I've had a student that has had Turner's. And then let's go down to this guy, and we're going to give him 2 diseases. Okay, so if we come down here, we're going to give him an extra X. So let's say you're looking here at 23 and you're like, oh my gosh, there's 3. Well, if you see 2 X's and a Y, it's called Klinefelter syndrome. So Klinefelter syndrome, you're still a guy, and just because you have an extra X, it doesn't mean that you're gay. Because some people say, will ask that, and they're not trying to be funny. They're like, oh, does that mean that, they're a little extra, they're more female? No, it just means that this fella is sterile. Okay, so he can't make sperm because he really doesn't go through puberty. This is a guy, as he grows up, he still looks like he did more like in 6th grade or younger. His body hasn't gone through. He doesn't have the muscle mass. He doesn't have the body hair. His voice may not change. He doesn't make those viable sperm. So I've also had a student who's had this. I would never have known. He told me separately and said, well, I've got this. This is what I do for it. And he gets hormone shots. And that helps him. It gives him the male testosterone, and it helps him because he actually had some facial hair. It's like, wow. And it was starting to build some muscle mass. So, there's different treatments that can help with these folks. So that's Klinefelter syndrome. And then over here, we're going to give them something called Patau syndrome or Patau syndrome. And that's an extra number 13. So we're going to give them, this is 13, trisomy 13. And this one's not going to be on your test as far as your exam, but I just wanted you to see how it can be pretty damaging to have another chromosome, and there's different degrees of it. So if you go around and you see one of these babies and it has an extra 13, then this is what it has. So let me show you some pictures of them, and then I will turn you loose to diagnose these patients, okay? All right, 13 right there. Add one more extra. So what we'll do is the next page in your packet is the karyotype gallery walk, okay? And you can walk around by yourself or you can work with a partner and see if you come up with the same thing. So what you'll do is when you look at one of these, it says total number of chromosomes. You're going to count all of them. You can count by twos, however, put down the total. And then it says count too many or too few. If they have too many, you'll put, well, yes or no. And if it has too many, if it has 47 or 48 or 45, you're going to put what number where there's a problem, okay? And then tell if it's a male or female and what evidence you have to show us. And then give us the diagnosis. So it might be normal or it might be one of these things that you see. So if you have questions, I'll be coming around. We'll see. I'll show you what some of these look like. Now, I am a believer that I don't think you guys would do this, but I'm a believer that if you make fun of somebody, it can come back on you. So some of these are pretty sad. The first one's not. Here's Turner syndrome. Slow. Maybe. Okay. So here's this little girl. It's a low hairline, short stature, small fingernails. She doesn't have a period. Let's see, poor breast development. So it's like she doesn't really go through puberty fully. Widely spaced nipples. So there's some facial features so that's Turner syndrome. All right, here's the Klinefelters with the male with the extra X. Let's see. So it says he's tall. Let's see. Poor beard growth. Osteoporosis. Let's see if there's a real guy that has it. That's not it. This guy has it. Widely spaced nipples. But really, would you know if a guy had this? Other than he wouldn't have it doesn't look like they fully go through puberty. You wouldn't know. The sad thing to me, though, would be unless you had a karyotype done, you wouldn't know you had this if you're a guy. It's like, wait a second, why am I not starting to develop like penis development, testing, just like everything starting to develop. And wait, what's going on? So then you would go to the doctor and they would probably do one of these and see. All right, here is Downs. Has everybody seen Down syndrome?
Yeah, I have a family member with that.
Really? Wow. Aren't they the nicest kids though, usually?
Yeah.
Doesn't mean they don't get mad or or get angry, but it must be pretty amazing to want to first smile over all the time, then frown, And they do have a pretty pleasant disposition. So it used to be all these kind of kids would just be locked up in institution, they'd kind of be allowed to wither away. So they usually have a speech impediment, their tongue is thick, they have some heart issues, there's some different, but they all have the same little eyes and have that, that face, that grin. Okay. Here is, now if you have a weak stomach, this one is kind of bad, okay? I'm kind of putting it out there. Okay, so this one is the trisomy 13. Obviously this baby didn't live. So some of these babies would have been born dead or miscarried. Some of them did survive, but you can see everything from the digits of the hands to look where the eyes, the eyes never formed, the nose is up here. This one just has a large cleft palate, and see how the eyes are kind of sunken in. Just having one extra chromosome 13. So, very rare and generally do not survive past 6 months of age. So, if you have a cleft palate like this, it's really hard to nurse, and to get so this is one of the main reasons that babies can be stillborn or miscarried, is there's a chromosomal problem. And nature kind of takes its course and kind of helps out. So, and that's that. All right, diagnosing kids. Hop up. See what you got. It should be in the same order. So whatever the number is the number of station it's at. So, here, just kind of circulate around. If you have questions, I'll be glad to walk through anything. This is your formative assessment before you have any that really count. So play some of my music. This is like, Let's see, what do I have on here? Do y'all like Coldplay? Do you know who Coldplay is? Do you like the Chainsmokers? Caleb, no?
We never listened to it.
Really? What do you listen to?
You?
Yeah.
Things you probably don't listen to.
Like what?
Lil Wayne.
Everything that Luke probably listens to.
Pretty much.
They went to a Little Yachty concert last year at Chapel Hill.
Not Yachty, Yachty.
Oh, they said Little Yachty. So you count them up, all of them, just count them up by twos. So the total number that you see that this kid would have.
So the pairs are like 1, 2, 3, 4, 5, 6, 7, 8. That's what I was thinking here.
That's how, yeah, so that would be the pairs. So if you have too many, so you count them up. So if you have 2, 4, 6, 8, 40, 42, 44, 45. So that would be the total number that you would put, that's right. And I have too few, and then tell us what pair made it too few. So you're gonna say number 23 next to that. Okay, and then is it a female or male?
We need male.
That's why.
No.
So that's one X, right? So if it only has X's, it's still female. So you'll put female and then tell us why. So you just have to put X. Plus, yep, so then you're gonna go, okay, so then this one will say 2 less, but then look at this one. where we don't have enough is number 23. So you'll put number 23 for the pair number right there. And then terms to the reminds me of painting that's in action. So because it has an X. Yeah. And just put X. And here, so their evidence is X. But since it doesn't have anything here, that's the X with the O, so you put X code. And then put the disease that means. That's only one X. So you just put normal, and there won't be any. Yep. Yeah, so you don't have to. But aren't these just 46? Oh wait, hold up. So 46. You got two for all of them. You have 2 for all of them, it's going to be 46. But now this one has an extra. So how many would you have? 46. Look. So is that 2 million or 2 million? Yes, at least. You show it. All right, you're at 2 million. Suppose that's 46, right? Is that 2 million? Put that open. And then what number was it? What pair number had 2 million? We go back to your notes. Which one is 2 million? So you might finish it. And then you're saying, but number 20. Right now, is this a finger or a meter? And what's your evidence? How many what things these do say? In the same box. What makes it in there? This one. So we have 2 guys here that we spend. Because you have 2 the same size. All right, now we're going to go over what y'all can start on. So this is next is answering those questions. And then we're going to end up doing them all, but nobody's following those. I think some of them are repeats, but okay, so what's the diagnosis? You have an extra 21, so you put in an extra 21. Here's your diagnosis. That's what you're putting. Okay. So it's not too huge, or one little dash in there. So it's new. So if it has an even 46, we can't run any other genetic tests. So from what you're going to say, we'll just say, I'll say, how normal is the test that this shows?
Baby.
All right, when y'all finish on the back of that sheet, there's some questions you can start on. View down clicker questions, we're in border view. Let's see what time it is. Okay, so go back to this. Let's see, where's your notes in the back? All right, so see right here, we said that you're missing that one. That's what the O means, this is sort of a placeholder. Got it. It's in good shape. All right, so we'll go over the answers in a minute of those. And the homework questions are the next sheet which some of these are the same. So it's the front and the back of the next sheet. So there are a couple questions you may not be able to answer, but just skip those. I think we're like 14 through 17, I think, on the back, but here's the homework. So let's go over the answers. Okay, so the first one, let's see. So Alexis, what'd you get for the first one? How many total chromosomes did you see?
47.
Okay, so 47. Everybody good? All right, too many or too few? All right, too many. Which pair had too many? All right, 21. Was it a girl or boy? Okay, so female. How'd you know? What two chromosomes made on female? XX or XY? Yep, XX. And then what was the diagnosis? What did you say the problem was with that baby? Yep, it is Downs. All right. Craig, go to number 2. So what did you get for total number of chromosomes for number 2? 47. For that one?
Oh, for 2.
Yeah, number 2. 46. Okay, not any too few or too many, so we just put a dash or skip it. What was the sex of the person? What did you write down? Because I know you got it. What did you get? Huh? Male? All right, how'd you know it was male? XY, and what was your diagnosis? Normal. Good. All right, Annette, number 3. What'd you get for that one? 46. Okay. So that one's not too many, too few. Okay. Male, female? Huh? Female? Okay. Normal. All right. Send number 4.
47.
47. Okay.
And no more number 30.
All right. So extra 23. Okay.
It was a male XY.
Oh, male XXY. So what's your diagnosis?
Klinefelters.
Klinefelters. Yep, you got it. All right, number 5. Elizabeth, what you get for number 5?
45.
45. Oh, wow. Okay. Too many or too few? All right, so number 23 only had 1. Okay, so female or male? Yep.
XO.
XO. Diagnosis? Yeah, Turner syndrome. You're right. All right, Caleb, number 6.
There was 47.
47. Okay.
Too many.
Okay.
There are 13.
13. Okay.
Female.
All right.
And it had Patel syndrome.
Yep. You got it. Nice. All right. Let's put this real quick. Okay, so for number 1, which of those is homologous? Number 2. Yep, it is. So homo means same. Just remember that. You know, people will say no homo. Homo does not mean gay. Homo means same. Or it means man, like human. So, yeah, same. All right, number 2. So hereditary information is, for most traits, is generally located on, what did y'all map?
The genes.
You map the genes on a chromosome, and that's why you did that. So, because a lot of times people want to choose number 2 for that question. So it is number 1. Okay, genes on chromosomes. All right, for these 2, you got 2 people. So for all of them, 1 through 22, which we circled, what kind of chromosomes are those? Number 4. Good. All right, the preparation to make these charts is known as karyotyping. They're all karyotypes. Okay, all right, so for the next one, the chromosomes are arranged in what kind of pairs? Yeah, you say homologous or homologous, either one's right. Okay, so pairs, you're right. All right, number 6. So this person has 3 chromosomes. Let's see. Oh no, my bad. I didn't read that right. The individual from whom these chromosomes were taken is a what? How do you know? Yep. For what pair?
23 pair.
Exactly. 23rd pair. And then the last one is, what disorder does this person have? All right, how do you know Downs? Y'all are good. Extra 21, you got it. So that makes it pretty easy. Let me go ahead and show you this, for this homework question on the next page. You can't see that. I mean, it is so doggone light that, I will tell you that it does have just one. All these are pairs, except the very last one. It's just hard to see. It's that very last one. Okay. So we've got 3 minutes. So instead of the board review, we can always do that on Monday. Let me give you a ticket out the door, okay? And it's called a Friday ticket out the door. So just pack everything up except a pencil. I have them laid out. There. My junk. Yeah, I'll leave that there in case you wanted to copy on me or notes. All right, we're not doing all these, so you don't have conflict. But put your name at the top. And we don't have time for 5, 4, 3, 2, 1. But what I want to know is, go down to where it says 3 things I've learned. So for this whole week, what is 3 new things that you've learned? Have a great weekend.
Alex Rodriguez and Madeline Blackwell to come to the main office, please. It's Alex Rodriguez, Madeline Blackwell to the main office.